Hello everyone, today we'll talk about the solution to the problem find the prefix common array of two arrays. The title of this problem is a bit scary. If you're solving it and you see the constraints being quite small, you get maybe even more scared. But as it turns out, this problem is very easy and the statement is not that long, so when you read it you see that, well, there is no problem here, really. Because we just want to say so we want to go through all the prefixes of A and B, so we are looking at the first k characters of A and k characters of B for the k prefix, and we just want to report the number of elements that appear in both of those prefixes. And it's even easier for us because both A and B are permutations. We can use the fact that they're permutations to replace a hash set which we'll be using with a simple array, but we won't be doing that in this solution. But really what this being a permutation gives us is that the permutation is in particular, it has no repeats. Every element is unique within it, which means that we can have quite a simple solution. That's because we can for every element from 1 to n, we'll see it twice when looking over both the arrays, and if at a given prefix of one and the other array we've already seen it twice, then it is indeed a repeat. It is indeed in the common prefix, let's say. Otherwise, it's not in the common prefix. So in other words, we have to, for I in 1, 2, 3, and so on, we have to report if, by taking the prefix of A and B of that length, we've seen, so how many elements we've seen twice. In other words, we'll be maintaining a set of seen elements. So notice that we don't really care whether or not the element comes from the first or the second array, because there are permutations. To see an element twice, it has to have come once from A and once from B. This is the number of elements we've seen already, and we have to calculate the result for every prefix. So we'll be going step by step. So we take the pair of elements, and now if we've seen the first element, we increase the result. And of course we add it to the set of seen elements. If we've seen the second element, we again increment the result. Again, we have to add the second element to the set of seen elements, and we append the result to our list. At the end, we return the list, and that is the whole solution. And notice that, of course, if any of those elements is the second appearance of that value, and the previous appearance was in some shorter prefix, then at that point it wasn't in seen, so we didn't add 1 to the result, and now we're adding 1 to the result. And the other case is that both v1 and v2 are equal, but that means that, of course, they didn't appear anywhere earlier. So here we will not increase the result because we haven't seen v1 yet. Then we add it to the list of seen elements, and then v2 we see that we have seen it because we've just added it because v1 and v2 are the same. So we increase the result only once, so everything works. And as it turns out, this problem is quite simple.